All right, so today we're going to be looking at our intro unit notes number 2, and so we're going to be solving inequalities. So today, what you should be saying is I will be able to solve an inequality and graph the solution. So we're going to be solving our inequalities basically just like we did yesterday with the equations. And then we're also going to be graphing them. So we're going to be doing some graphing on those number lines like we did yesterday. So the main difference with inequalities is that an inequality can have infinitely many solutions. So remember, just like yesterday when we had infinitely many solutions, that means we're going to do some shading. So infinitely many. That was an awful N. There we go. Unlike an equation, which has one solution. So equations only have one solution. Okay, so with our inequalities, they're going to have infinitely many. So remember, we do have some inequality basics, so we have to remember what our symbols mean. This first one looks like an L, so anytime we get one that looks like an L, that means we're going to have a less than. So anytime we just have less than, okay, so it's not equal to, it's just less than, that means we're going to have an open dot when we graph it. That means that that dot isn't actually a solution, okay? The next one, it's facing the other direction, so that's going to be greater than. The next one, we have less than or equal to. See how it has that or equal to there? Okay, so less than or equal to. Okay, so I forgot to talk about the dot type for greater than. My bad. So since it's just greater than, it's not equal to, it's going to be an open dot because it's not going to be equal to it, just greater than. The less than or equal to, that's going to be a closed dot because it has that or equal to. So that's going to be a closed dot. So it's going to be filled in. Okay, and then the last one, we have the greater than symbol with the equal sign. So that's going to be greater than or equal to. And then this one is also going to be an open dot. So looking at these, we're first going to test some solutions. So remember, we're always testing solutions to see if they're true. So a solution of the inequality is a number that makes the inequality true. Just like with equations, our inequalities have to be true as well. So looking at our first one, it says graph the solution to each inequality. Okay, we know we're going to be starting at 5. So we can go ahead and start by setting up our number line with 5, then a few numbers that are bigger, and a few numbers that are smaller. So the first number that we're going to test is 5. So I want to know, is 5 a solution? That's where we're going to take that 5 and plug it in. So I'll have 5 is greater than or equal to 5. Well, that right there is true because it has the or equal to. So we know that this is true. So that means it is a solution. Since we know that that's a solution, that means it's going to have a solid dot above the 5 because we know that the 5 is a solution, so it gets a dot. So now I have to check the other two to figure out where else are we going to need to shade. So now we're going to take the 3 and plug it in. So I'll have 3 is greater than or equal to 5. Well, is 3 actually greater than or equal to 5? Nope, it sure isn't. So this is going to be false. So this is not a solution. So that means we do not shade there. We're not going to want to shade where it's false. So I'm actually going to go to that 3. I'm going to put a big F over it for false. So now we're going to check the 7. We'll see if the 7 works. So we're going to plug it in. and we'll get 7 is greater than or equal to 5. That is true. Okay, so since that's true, that means we know that this is a solution. So that's where another dot would be. So that means everything on this side is going to be a solution. So we're going to shade everything on this side. Because we only shade where the solutions are. That means you could plug in any of these numbers over here and they would all be true. Because all those numbers are greater than or equal to 5. All right, let's do the next one. We have x plus 9 is less than 5. So we got to get that x all by itself. So we're going to subtract the 9 over. And we'll get x is less than 5 minus 9 gives me negative 4. So now we're going to kind of get our number line set up so we can figure out where we need to shade. So we're going to put the negative 4 in the middle, a few numbers that are bigger, and a few numbers that are smaller. Okay. So we're going to start by checking the negative 4. So we're going to take that negative 4 and we're going to plug it in. And we'll get negative 4 is less than negative 4. Well, is that true? It sure isn't. That's false. So since it's false, that means it's not a solution. So that means we can't actually put a solid dot over the 4. That right there is why it's going to have an open dot. Okay, it's going to have an open dot over the negative 4. So now we're going to do the same thing for the 1 and the negative 5 to figure out where we need to shade. So we're going to take that 1 and plug it in. So I'll have 1 is less than negative 4. That's also going to be false because positive numbers are always going to be greater than negative numbers. So that's going to be false. So that means we're going to go put a big F over the 1. Well, 1 would be way over here, so that'd be an F for false. So now let's check negative 5. And we'll get negative 5, maybe, there we go, is less than negative 4. Well, that is true. Negative 5 is definitely less than negative 4. So that means that's true. That means that's our solution. So we're going to shade everything with the negative 5. Because that means any of these numbers over here are going to be solutions to my inequality. All of those are going to be solutions. All right. So just a little bit of review. Number 3 is kind of what we've been talking about, where we've been checking and testing our solutions. So it says, given the following inequality, 3 times x minus 1 is less than or equal to 10, determine if 4 is a solution. So we want to know if 4 is the solution. So we're going to take that 4 and plug it in for the x. So that'll give me 3 times 4 minus 1 is less than or equal to 10. All I did was take that 4 and plug it in for the x. So now I have to simplify. You have to simplify what's inside the parentheses first. So we'll have 3 times 4 minus 1 gives me 3. Is less than or equal to 10. And now we just have to simplify. 3 times 3 will give me 9 is less than or equal to 10, which is true. Okay, so that means 4 is a solution. All right, if you have any questions about the first page, make sure you're asking, okay, getting help and asking those questions. If not, let's flip over to the back page. So our big reminder here is that we have our golden rule of inequality. So whenever you multiply or divide by a negative number, maybe, there we go. Okay, so anytime you multiply or divide by a negative number, oh, I already had a number down there. Oops, so ignore that. The inequality flips. So that means it changes direction. That means if it was less than, it becomes greater than. If it was greater than or equal to, it becomes less than or equal to. It just flips. So we're going to go ahead and look at a few problems, and we're going to see if we have to flip our inequality. So the first one is 10x minus 2 minus 6x is greater than or equal to 7 plus 3x. So the left side, we have to combine like terms. So 10x minus 6x will give me 4x minus 2 is greater than or equal to 7 plus 3x. From here, we need to get all the x's on the same side. So we're going to subtract 3x. That cancels. 3x, or 4x minus 3x gives me 1x minus 2 is greater than or equal to 7. From here, we just need to get the x all by itself. Same thing with equations and inequalities. We're always going to get that x by itself. So that means I'm going to add 2 to both sides. And we'll get x is greater than or equal to 9. So now we do need to get this graphed. So the 9 goes in the middle. Few numbers that are bigger, few numbers that are smaller. So thinking of this, we've already talked about if it's or equal to, that means it gets a solid dot. So we're going to put a solid dot over the 9 because it's or equal to the 9. Okay, and we want all the numbers that are greater than or equal to 9. Well, I want you to think about it. Oh shoot, I totally messed up that number line. Wow. My bad, guys. So we had 9, 10, 11, and then smaller numbers are going to be 8 and 7. Wow. All right. Well, hopefully I don't mess up any more like that. All right. So like I was saying, we want all the numbers that are greater than or equal to 9. Well, 7's not greater than or equal to 9, so we're not going to shade that side. Whereas on this side, 10 and 11 are both greater than 9. So that means those are solutions. So we're going to shade all of those solutions. All right. So now we've got number 5. We have 2x minus 3x minus 6 is greater than negative 8. So we're going to start by combining like terms. We have 2x and 3x on the same side. So we're going to combine those two. 2x minus 3x gives me negative 1x. Minus 6 is greater than negative 8. Now we need to get the x all by itself. So we're going to add the 6 over. That'll give me negative 1x is greater than negative 8 plus 6 gives me negative 2. And last but not least, we have to get rid of that negative in front of the x. So we're going to divide out the negative 1. Those will cancel. And I'll have x. This right here is where my inequality has to flip. So it has to flip and it becomes less than 2. Because negative 2 divided by negative 1 gives me a positive 2. So notice our inequality flipped. Okay, that's the key thing for that problem. So from here, we're going to start with a 2 in the middle. Two numbers bigger, a few numbers smaller. It is just less than. So since it is just less than, we're going to have an open dot over the 2. And it's less than, so we want all the numbers that are less than 2. Well, 0 and 1 are both less than 2. So we're going to shade on that side. All right. If you have questions about those graphs, please make sure you're asking. Okay, our last problem, just a little bit of review, those word problems that we're practicing setting up. So it says, your little brother has decided he wants a rectangular sandbox in the backyard. You decide to be nice and build it for him. So you know you want the length to be 4 feet longer than the width, but you only have enough materials for the sides to be a total of 26 feet. So, rectangular sandbox. Sorry about that, guys. So we know we want the length to be 4 feet longer than the width. If something is longer, that means we're adding to it. So it's going to have a plus 4 in there somewhere. But we didn't actually talk about the width. Okay, we never talked about it once. So that means we're just going to call the width x. And then we said that the length was 4 feet longer. So that means it's just going to be x plus 4. And we know all of that needs to total 26. All right. So looking at this, it says, can you make an equation to describe the situation? Okay, an equation just means that we're going to add up all those sides and write it out like an equation that we were solving and working on. Okay, So to find the perimeter, we're describing and talking about the perimeter, the materials. That means we just add up all the sides. So we're going to have x plus 4 plus x plus 4. And that's all going to equal, well, just like we wrote it, 26. Okay, so from here you can combine your like terms. I have 1, 2, 3, 4 x's, so 4x. And then 14, or 4 plus 4 gives me plus 8 equals 26. And we will practice solving these and find out what all the different pieces mean in later notes. So right now we're just practicing setting up the equation. All right, once you're finished, you can move on to your homework.